At 0712 local time, a mission controller, hunched in a bunker near Pava, observes 18 green blips crossing into Russian territory. Their trajectory remains unwavering, their velocity constant. Between those signals and Cherepovets stretches roughly 800 kilometers of Russian landscape. Imagine the span from New York to Detroit, leading directly toward a critical hub of artillery ammunition manufacturing. Neither the controller nor anyone watching realizes that 30 kilometers ahead, a Tor M2 system lies dormant, acquiring targets, locking, and unleashing its payload. Interceptors race toward the formation with only 35 seconds until contact. At 3 times the speed of sound, the missiles streak across the sky. Both find their marks. Fiberglass and composite fragments scatter like confetti across the Zhukovka forest. 2 aircraft eliminated. 16 continue their northeastern push. What just engaged this formation represents Russia's elite air defense response, the 9 M38 interceptor, functioning as a gatekeeper at the entrance to the nation's defensive network. Reaching 3 times the speed of sound, it boasts a 15-kilometer range specifically engineered to intercept cruise missiles during their final half-minute of flight. Each costs approximately what a luxury SUV sells for. The Tor system just expended 2 of these sophisticated weapons against unmanned platforms valued at $55,000 each. Constructed from plywood and composite materials at a facility called Firepoint, these machines feature a single electric motor, GPS navigation, inertial guidance systems, and a warhead mounted in the nose cone. They represent crude engineering elevated to strategic purpose. Russian crews understand the arithmetic has shifted against them. Those positioned later in the defensive chain may never discharge their weapons at all. The controller in Pava watches 2 signals vanish from his display. His briefing predicted losing 4 drones within 60 minutes. 2 casualties by minute 12 means they're ahead of schedule. The 2 that just disappeared responded to the call signs Anvil 04 and Anvil 09. Of the original 18 airframes that breached the border, 12 carried designations from the Anvil series. These represent the Firepoint platforms that the Tor just targeted. The remaining 6 responded to Hammer, designating longer-range strike variants. Each Hammer carries 75 kilograms of explosive payload in the forward section. Unit cost runs to $200,000. The controller's inventory now shows 10 remaining Anvils and 6 remaining Hammers. Over at Barant's Sector Command, a duty officer receives the notification and already grasps the pattern unfolding. A coordinated swarm moving low, traveling beyond the engagement range of his stationed batteries. Each drone's onboard targeting apparatus possesses knowledge of only the next waypoint on its route. Consequently, nothing recovered from wreckage will reveal the ultimate objective. He selects another telephone handset and dials Kotylovo Air Base, situated 500 kilometers to the north. The Alert 5 squadron operates MiG-31 BMS fighters. Scrambling a MiG-31 to pursue a plywood aircraft represents the sort of equation that keeps Russian logistics personnel awake through the night. The jet consumes $20,000 in fuel per hour, chasing something cheaper than an entry-level automobile. They launch anyway, because failure to respond carries consequences. The duty officer who declined to scramble becomes the person sitting across a table in Moscow the following week, answering uncomfortable questions. Call sign Corone 71 achieves airborne status inside 4 minutes. 46 tons of fighter accelerates through 7,500 meters and reaches Mach 1.4 within 2 minutes. covering the equivalent distance from New York to Philadelphia in 4 minutes, before orienting its nose toward 16 slower aircraft. The Zaslon AM radar broadcasts across the sector at maximum output. No other equipment mounted to a fighter generates this magnitude of raw electromagnetic power. At a distance of 50 kilometers ahead, 10 anvils and 6 hammers now sit bathed within the most intense radar illumination the Russian Air Force can produce, completely defenseless against electronic attack, possessing zero agility, incapable of outrunning anything fired their direction. They maintain straight and level flight at 170 kilometers per hour, because this represents the solitary maneuver they can execute. Should the Russian R-77 perform as designed, the entire formation expires within 90 seconds. The pilot has executed this intercept scenario 100 times in simulation, against Tomahawks, against jamming, against F-16s at Mach 0.9. Never against anything this deliberately slow. He pulls back the throttle. This marks the first counterintuitive decision of his career. He descends toward 3,000 meters to improve his firing geometry, positions himself for a head-on pass, acquires the lead target, and fires. At 18 seconds of flight, the R-77's internal radar takes one quick observation of the designated target and immediately rejects it. The Doppler filter classifies the drone as ground clutter and deactivates itself. The missile embeds itself deep within the forest outside Tyr, becoming $500,000 worth of Russian ordnance transformed into kindling. This R-77M, called AA-12 Adder by NATO analysts, serves as Russia's primary long-range air-to-air weapon. It carries a 90-kilogram active radar seeker that detects targets by transmitting a signal and listening for reflections. Think of it as shouting into a darkened room and waiting for the echo to return. Its effective range extends 110 kilometers. The system was built to destroy F-16s and B-52s from beyond the horizon. It represents the most technically accomplished missile in Koron 71's arsenal, yet possessed precisely one failure mode, which it discovered. Deploying a Mach 3 interceptor against a plywood drone resembles dispatching a NASCAR driver to chase a child on a tricycle and somehow losing that race. The explanation for why a Mach 3 interceptor armed with a $500,000 missile just failed against a plywood aircraft centers entirely on Doppler physics. Every radar-guided missile employs a pulse Doppler seeker that tracks its target according to the way radar echoes shift as the target moves. A fighter traveling at Mach 1 generates an enormous Doppler signature. A drone moving at 170 kilometers per hour generates almost nothing. The filter deliberately ignores anything slower than approximately 100 knots, because such slow speeds resemble ground clutter. It mirrors the difference between tracking a race car traveling down a highway and tracking a bicycle on that same highway. The bicycle becomes the background, filtered away identically to how human perception works. The pilot performs mental calculations. He possesses 4 missiles remaining against 16 targets. Even if the next R-77 somehow succeeds, and now he has zero confidence it will, his ammunition still falls short of the formation's size. He commits one additional missile from a different aspect, receives the identical in-flight rejection, and radios the sector. Missiles expended, no hits achieved. Requesting aerial refueling support. 16 drones transited through the effective envelope of Russia's finest interceptor and emerged unscathed because their velocity place them below the detection threshold. In Pava, the controller draws his first truly unrestricted breath in 9 minutes. The fighter's radar signature departs his scope, traveling westward. That was the sole interceptor capable of catching them. 16 drones pressing northeast. Russia's premier fighter just squandered $1 million in missiles, with nothing to show for it. Next obstacle facing the formation involves a defensive infrastructure, consuming billions in Russian investment. The decision before the man in the command trailer becomes increasingly grave. 3 hours into the operation, an S-400 Triumph battery, positioned on Moscow's perimeter, detects all 16 surviving drones on its 91N6E Big Bird radar from 152 kilometers away. The battery commander watches them advance across his display. Every procedure he trained on throughout his career suggests engaging a hostile formation once it enters 400-kilometer parameters. He does not pick up his communications handset. Unknown to him, choosing restraint just handed Ukraine something the remaining defensive layers cannot provide: a 300-kilometer corridor penetrating straight into European Russia's interior. The S-400 represents the supreme achievement of Russia's air defense inventory. It features a 400-kilometer engagement radius and Mach 14 interceptors, specifically designed to eliminate F-35s and ballistic warheads approaching from the fringes of space. Each 40N6 missile costs approximately $4 million, equivalent to a Manhattan townhouse with a supercar parked in the driveway. But the commander's actual concern transcends cost considerations and centers on magazine capacity. Each launcher carries exactly 4 missiles. If he depletes them against this formation and a storm shadow appears immediately afterward, something genuinely requiring a $4 million interceptor, his defense becomes compromised. He observes the display for 6 minutes while the contacts fade from the eastern edge. He timestamps the moment in his logbook and hopes another battery, positioned elsewhere, possesses the ammunition required for what approaches. The controller in Poltava watches 16 signals cross the inner defensive perimeter completely untouched. This appears miraculous on paper. In operational reality, it represents a trap closing. Every GPS receiver integrated into all 16 airframes goes silent simultaneously. Not individual devices, all 16 at once. The Pol 21 jamming network just flooded the atmosphere with electronic noise on every frequency the satellites utilize for ground communication. This system achieves its objective by broadcasting noise across the precise frequencies GPS satellites use to transmit data to receivers below. Tower-mounted installations, hundreds of units synchronizing simultaneously. A solitary Pol 21 installation covers territory comparable to a small metropolitan area. Dozens overlap to blanket the entire airspace between the border and Moscow. The satellites continue their broadcasts above, their signals unchanged. Yet the ground-based noise becomes so overwhelming that receivers cannot perceive them. Similar to jamming a telephone conversation by igniting a blowtorch against the microphone. Frequency jumping cannot overcome this obstacle because all bands experience simultaneous flooding. Russia built this layer after 18 months of observing Ukrainian drones rely on GPS correction. It was supposed to function as the impenetrable barrier. In Pava, the controller experiences his entire formation lose navigational awareness in real time. The heading indicators on 10 drones begin fluctuating. Their inertial compass systems become unreliable navigators now. Dead reckoning governs their flight, traveling on memory alone, comparable to driving toward a city you've never visited using only a compass and your last known direction before someone severed your connection. 2 of those 10 begin deviating from course. One drifter gradually curves toward a forest outside RV and detonates against a pine tree. $55,000 worth of aircraft defeated by vegetation minding its own business. Another drifter descends toward a field and goes dark. The controller has prepared for this possibility throughout 2 years of planning, yet still must consciously remind himself to continue breathing. He searches for 6 specific signals within the formation, 6 that are supposed to maintain steady flight, 6 that everything depends on. If they waver, the operation fails. If they hold steady, the operation survives. 6 signals maintain course. The other 8 blind drones are navigating through the gap using dead reckoning alone, staying within a kilometer or 2 of their original planned trajectory, relying purely on momentum and their previously recorded heading. They will probably penetrate deeper, though nobody in Pava can guarantee the duration. But the 6 that truly matter refuse to guess. They navigate by reading the terrain. The 6 signals that don't fluctuate possess no obvious camera mounted on the fuselage, but the optical system sits concealed behind a compact, dark panel. This represents a Skynode S, manufactured by Ion, a Swiss-American autonomy corporation whose camera-guided navigation system has been quietly striking Russian installations for 2 years. The 6 drones carrying this hardware are Ukrainian-manufactured Ludis, featuring a single rear-mounted propeller, each equipped with 75 kilograms of warhead, achieving 1,000-kilometer range, priced at $200,000 per unit. Before departure, Ukrainian technicians loaded every Skynode with a visual library of the complete route. Not GPS coordinates, but photographs. The bend in the Volga outside Tyr, the rail junction at Bologoye, the forest margins north of Bolochoke. Every 20 seconds, the nose camera compares live imagery against the stored map and executes corrections. It represents the distinction between calling for directions and reading street signs personally. If somebody jams your telephone, navigation becomes impossible. If you can read street signs, jamming becomes irrelevant. The Pole 21 network presently flooding the sky represents the electronic equivalent of severing the phone line in a city where every driver already possesses a paper map stashed in the glove compartment. A single device fitting inside a shoebox just rendered a multi-hundred-million-dollar jamming infrastructure completely impotent for the remaining 600 kilometers of travel. In Pava, 14 signals maintain course. 8 anvils navigate blind and remain fortunate. 6 hammers observe everything. 2 drone variants, 1 unified purpose. 15 kilometers remaining. A Pantsir SM battery operating in the Gap Corridor airspace detects the formation at 24 kilometers using its IRS-23 radar. This battery commander has maintained watch over this sector for 60 minutes. He received the Baran's report. He observed 16 contacts avoid disappearing from any other radar scope, and he comprehends precisely what this signifies. The formation possesses a navigation system his electronic countermeasures cannot disrupt. This problem belongs entirely to him now. His magazine is fully loaded, and he tracks 16 targets. In principle, this provides 3 shots per aircraft, with spare ammunition remaining. In reality, his mini-missiles possess a 7-kilometer effective engagement window, and 170 km/h targets cross his firing parameters in under 3 minutes. He receives 1 substantial salvo and 1 weaker follow-up attack. Failing the initial strike means the drone escapes beyond his envelope before reloading concludes. He initiates fire at 18 kilometers. A projectile launches from the left rail, smaller compared to anything the Pantsir previously deployed. Approximately half the previous length, roughly a quarter of the mass. Flight duration to the lead aircraft spans under 9 seconds. The impact proves direct. The anvil fragments explosively in mid-flight. Plywood and composite pieces snow down across a wheat field. Until 1 year prior, every Pantsir battery carried 12 complete-size 57E6 interceptors. Russia monitored 18 months of Ukrainian drone attacks, systematically exhausting those magazines one for one against $55,000 unmanned platforms, and determined it required a less expensive missile solution. The answer involved the mini-missile. 4 tubes occupy the space previously holding each original missile. One current Pantsir SM carries up to 48 mini-missiles, rather than the prior 12. The range diminished, 7 kilometers versus the previous 20. The gauge shotgun to a pellet rifle. Every individual shot delivers less force, yet you can fire 4 times as frequently before requiring reloading, which becomes crucial when adversaries arrive in groups of 18. Each mini-missile runs between $30,000 to $50,000 against a $55,000 decoy platform. Finally, Russia discovered an equation it could afford if the commander targets correctly. 2 additional missiles depart the same launcher within 12 seconds. 2 more drones vanish. The commander prioritizes the forward contacts. This reflects standard doctrine. Nearest threats constitute the priority. A 4th, 5th, 6th, and 7th leave the rail across 40 seconds. 3 miss their targets. The 4th generates a detonation sufficiently close to a trailing contact that shrapnel shears the wing. The stricken aircraft enters a slow, flat rotation. Impact occurs within the forest. The commander studies his scope and recognizes 2 simultaneous realizations. He consumed 7 mini-missiles to eliminate 4 drones. Additionally, the 4 he destroyed came exclusively from the forward 12. The rear 6, the ones transmitting a different radar signature, continue advancing unopposed. What the Pantsir commander figured out 12 seconds past the optimal moment reveals Ukraine's actual strategy. Ukraine brought more than 2 drone variants. Ukraine constructed the formation according to the very doctrine he learned during training. Forward contacts first, nearest threats prioritized. Every Pantsir commander receives this instruction from the initial day of service. It also represents precisely what Ukraine anticipated. The anvils composed the leading wave because Ukraine understood the Pantsir would fire at the leading wave. The hammers trail behind because Ukraine calculated that by the moment the radar identified which contact carried the 75-kilogram payload, those contacts would already be positioning themselves inside the rearmost boundary of the engagement window, the boundary those mini-missiles cannot reach. 6 hammers entered Pantsir airspace. 5 exited the opposite side. Transiting through a corridor, the anvils purchased 1 mini-missile at a time. Every anvil that detonated represented a Pantsir mini-missile that will not be available against the hammers. $55,000 of plywood, trading itself for $50,000 of Russian interceptor and 1 opening in the passage. The anvils maintain straight flight and formation integrity because this represents their function. The strategy only works if the hammers penetrate the defense. The anvils were never intended to survive. The commander commits 2 additional shots anyway. Neither connects. 20 kilometers separate the formation from the target. The Panzer commander has expended 14 missiles for 4 kills. 34 rounds remain accessible. 5 hammers still approach with 75 kilograms each. The next battery corridor discharged its weapons 11 minutes prior. 3 problems converge simultaneously. A single flight path that shows no deflection. 23 kilometers from Cherepovets, a final mobile group attempts desperate intervention. A compact airframe launches from a catapult rail positioned in a wheat field. No rocket exhaust, simply a sharp electric whine as it climbs aggressively on an electric motor. It reaches a trailing anvil at 200 kilometers per hour and collides. The anvil tumbles through the air. The interceptor disintegrates upon impact. This represents a catapult-launched drone without a warhead, merely a dense forward section and sufficient velocity to strike a slower target. Artificial intelligence assists visual tracking. Cost represents a fraction of a Panzer mini-missile, a lawn dart equipped with guidance electronics and purpose. The Ukrainians no longer monopolize crude, inexpensive aircraft. Russians are learning as well. A second interceptor launches 2 seconds after the first and glides off target toward the forest. A third never achieves separation from the launcher. Optical lock lost. In Poltava, the controller counts his remaining signals. 9 dots, 5 hammers, 4 anvils, positioned 15 kilometers from the objective. Everything forward depends on what the hammers accomplish in the next 60 seconds. At 8 kilometers, the lead hammer's trajectory indicator shifts by half a degree on the controller's display, then another half degree. Subsequently, it locks onto a different heading. The remaining 4 hammers follow within moments, each executing its individual correction toward a separate angle. The formation transforms. It no longer functions as a unified group. It transforms into 5 individual attackers, each committed to a specific section of the installation. The Skynode S on board each hammer transitions modes. Navigation ceases. Targeting initiates. Ground mapping mode terminates. Target mapping mode activates. Preloaded satellite pictures of Cherepovets-Azot become the reference database. Each aircraft reading the specific rectangular footprint of ammonia, one's reactor column. The specific pipe assembly characterizing ammonia 2. 5 attackers, 5 objectives. 1 anvil diverges from the formation, utilizing its older guidance apparatus, drifts away from its designated target by perhaps 100 meters, and strikes directly onto a metal lattice welded across the top of a substantial spherical tank positioned on the facility's north perimeter. A brief, intense flash, a spray of debris. No secondary explosion follows. The tank sitting underneath sustains scorch marks, but remains structurally sound. The Russian personnel monitoring that sphere from the control room, watching it withstand a direct impact, probably believe the protective cage performed its function. It did, simply not the function they assumed. 3 years prior, Valagro welded those protective lattices across every liquid ammonia storage sphere at Cherepovets-Azot complex. Following earlier strike campaigns, Ukrainian targeting personnel reviewed the satellite information. Throughout operational preparation, every sphere wearing protection became a hardened defensive objective. Every reactor column, every compressor building, every electrical hub sitting unprotected in the equivalent frame became precisely the opposite. Undefended, unmonitored, positioned exactly where 5 hammers had already oriented themselves. Russia's anti-drone expenditure failed to safeguard the complex. Instead, it handed Ukraine the annotated targeting data. Hammer 1 identifies the Ammonia 1 reactor column from satellite information inserted into its navigational computer 2 days prior, inside a hangar adjacent to Poltava. The Sky node confirms identification by matching pipe architecture, structural dimensions, inbound vector, and commits to the approach. No additional directional modifications become necessary. The aircraft has traveled 800 kilometers to scrutinize this exact rectangle. It descends toward the target. 75 kilograms of high explosive meet a column operating at 200 bar pressure. The column does not simply explode. It ruptures, releases, and ignites. Each stage occurs within 1/10 of a second. Every cubic meter of discharged substance within 40 meters immediately catches fire at once. A fireball ascends 300 meters above Gate 6 and establishes a smoke column detectable from orbital altitude. This fireball represents significantly more than the 75-kilogram warhead's energy alone. The facility completes what the warhead commenced. 200 bar internal pressure, 2,900 psi, ammonia, hydrogen, and overheated synthesis gas at maximum operating volume, striking a reactor column comparable to detonating a pressure vessel filled with gasoline on your kitchen stove. The warhead furnishes 10% of the total energy. The facility provides the remaining 90%. 60 minutes earlier, this column produced 1,700 tons of ammonia every 24 hours. Currently, it manufactures ash and metal fragments. The 4 subsequent hammers execute the identical attack sequence against different installations. Every aircraft reads its preloaded imagery against the specific construction it was designed to target. Hammer 2 matches the compressor section of Ammonia 2 against its loaded map, verifies alignment, and descends directly into the second manufacturing line's core. Hammer 3 recognizes the ammonium nitrate facility, the location where explosive substance for Russian artillery ammunition gets formulated, from the stored imagery, and commits nose first. Hammer 4 discovers the nitric acid manufacturing unit on its second camera pass and commits. Hammer 5 demonstrates the most patience among the 5. It bypasses the obvious targets and races toward the electrical transformer station, providing power to the offline Ammonia 3 unit, guaranteeing that subsequent reconstruction efforts cannot achieve operational status until replacement electrical infrastructure stands ready. Within Cherepovets' industrial zone, 2 residents retrieve their communication devices the moment network service restores, and distribute recordings of the smoke column. The following day, both receive summons to a police facility and face compulsion to broadcast public apologies on government-controlled social channels for documentation of an assault their leadership will categorically deny ever transpired.